CLI and a cross-platform IDE for C and C++. Download now.
All right, we're going to have to go fast, so pay attention. Okay, I hate printf debugging, right? I hate the way that so many people just rely on printf debugging as the first thing. And I don't say this only because, like, if you know me, you probably know that I've spent like 10 plus years trying to make the world's best debugger. So obviously, like, I have a dog in this fight. But I didn't start, like, I don't hate printf debugging because I started a debugger company. I started a debugger company because I hate printf debugging. But even I have to admit, there are times when it's like, it's all you've got, right? I mean, those of us who make the tools, we try as hard as we can to perturb the program the minimum amount. And like in the case of undo, if we have to, we try and perturb it in a way that like make race conditions and things more likely to occur. But Heisenbugs principle is a thing. And in the end, if you're touching the program, you can cause it to do different things, and you can cause the bug to go away. And sometimes all we're left with is printf debugging. But I thought that, so does printf debugging have to be quite as bad as it is? If we just do a regular printf, it's like 5 microseconds. Now, most of that's just a regular printf, so most of that's time spent updating the screen and stuff. Anyone sensible would do more like an fprintf, which, by the way, could be like IO streams or anything else. They're all built on top of fprintf, which comes in at 133 nanoseconds, which is like better, but still seems kind of slow, and particularly scales really badly. As we run it over multiple cores, just the performance really degrades hopelessly. And it's even worse than that, because what's going on is libc has this great big dirty lock in the middle of it. When you call write, it takes a lock. And so not only does that perform badly, it's going to really perturb the scheduling order of the different threads because they all contend on this lock. So it's terrible. Printf is terrible for debugging these kind of Heisenbug race condition type issues. So I went looking for other things. There's a thing called speedlog, which is actually quite a nice library, has a lot going for it, but speed does not seem to be one of the things. It also has like this great big dirty mutex in the middle of it, so it has exactly the same scaling problems as fprintf does. So I thought, well, maybe you can kind of slightly roll our own with sprintf, and that's much better, right? Because sprintf does not take a lock. So this is cool. It's actually slightly slower for the single threaded case, and what I did was like get rid of the locks by having an atomically incremented index into this managed log buffer. Thread 1 does an atomic increment on the index and can start writing into it, and then meanwhile thread 2 can also atomically increment the index and start writing in, so it's lock free, system call free, and then we can just mmap the thing. And so this is really nice, right? So you do a file back to mmap, and this gets rid of the problem that it's all an in-memory log, but when your program crashes, have I got all the log message, right? So have I got this truncated output? And with mmap, no problem, no system calls, no locks, no truncated output. Very nice. But I thought it's still like a shame that the single threaded case is worse, 195 nanosecond. That's partly because what I'm doing is 2 calls to sprintf, one to work out how many bytes to copy, and then a second one to actually copy the bytes. And I thought, well, maybe I could do something like fixed length buffers with some overspill or something. But then I thought, well, maybe we could do better and just, why don't we just write the pointers? So I ended up making a thing called L3, which is a lightweight logging library, which it turns out is like strategically massively misaligned with my entire business. And I think probably kind of turns out I think that I'm not very good at strategy. I just like building shit. But company's now profitable, so the VCs can't fire me anymore. So I did this. And yeah, so we can get down to 1 nanosecond and it scales better by just, let's get rid of all the string processing entirely and just copy pointers to strings into the log buffer, right? So we've got this little structure. It also contains thread ID and some other stuff that's useful and some arguments. And then there's a header thing as well that goes on the front, and we mmap the whole thing just like before. Great, except obviously now my log contains just pointers, which is not very useful, right? What we want is the strings. But it turns out you can post-process that log and work out the strings, because the way this stuff works is when I'm running a program, I've got an executable, it's got a .text section that gets mapped into memory with code, it's got .data section, which is data, which also gets mapped into memory, and it's got the RO data section, which contains all the strings. So I can take the pointer, work out the offset from the start of that section, apply that offset back to the RO data section in my executable, and find the original string, then post-process it, or put all the arguments in. All works great. And to make the single-threaded case go even faster, libc has a thing to tell you if you're single-threaded, so we can like jump over the lock prefix, and that saves like 10 nanoseconds or something, and is super cool. So it's all up there on GitHub. You could write the code yourself, to be honest, not very hard, but you might as well take it from there. Future work, I'd like to make it so we have a log per sync per log per CPU, which would be like kind of cool, but has some problems with working out the ordering. Anyway, that's it.